Welcome to my online class today. Welcome to Mr. Palm's online class. How are you doing? Hope you are good. So today we are looking into chemistry, and the topic we have here is entropy. Entropy. So entropy, enthalpy, and gives free energy. Entropy, enthalpy, and gives free energy. Gives free energy. The three are the yardstick, you understand, that we talk about in spontaneity of reaction. Spontaneity of reaction. To show if a chemical reaction is spontaneous. Spontaneous. When you say a chemical reaction is spontaneous, it means the chemical reaction can occur on its own. You understand? It can proceed on its own without addition of any energy, without adding any energy to it. The reaction proceeds on its own. You understand me now? So the yardstick that we use is entropy, enthalpy, and free energy. So, but for this class, I will discuss on entropy. Entropy. Okay. Now, what is entropy? Entropy. Entropy is a measure of degree, measure of degree of randomness, randomness or disorderliness, disorderliness in a system. Entropy is defined as a measure of degree of randomness or disorderliness in a system. You understand me now? And entropy has a symbol. The symbol is S. You understand me now? So S stands for entropy. You understand me now? So entropy is just talking about the disorderliness, randomness, you understand, in the system. Let me give you an example. You know, there are three states of matter. We have solid, liquid, and gas. Solid, liquid, and gas. When you look at the way the molecules are arranged in them, you know, solid, let's say this is solid, then we have liquid, and we have gas. You know, the molecules of solid are closely packed together. Solid molecules are always closely packed. They are closely packed together. Closely. You understand what I mean now? They are closely packed together. Liquid are a little bit, they are a little bit random. You understand me now? They have some space in them. For example, look at it. Liquids may still have some spaces in them. You can see. And gas, as they are mostly random. So let's see. Gas, a molecule can be here, another one can be here. You understand what I mean now? So gas spread the most. The molecules spread the most. You understand what I mean now? So which means that solid, there is no, you know, randomness, no disorder. They are well arranged. The molecules are closely packed. No disorder in them. They are not scattered. You understand what I mean now? So that's solid. Now followed by liquids are a little bit scattered. The molecules are a little bit, you know, scattered. So there is a disorder in it. While gas are mostly, you know, in random. You understand what I mean now? So which means that gas has the highest entropy. They are mostly scattered. The molecules are in disorder mostly. You understand what I mean now? So gas has the highest entropy, and solid has the least or lowest entropy, while liquid falls in the middle. You know what I mean now? So that's all by entropy. Now let me give you some examples to show entropy. Let me give you some examples to show entropy. Well, let's say now you know we have three states of matter. Let me use water for example. Water, water, water. Water can be in the form of ice, liquid, and gas. So liquid, ice is solid state. You know, when you place your water in the refrigerator, it becomes ice. That's solid state. Liquid is your water. So water, for example, your liquid, and your gas is like steam. For example, steam. You know, when you put some water on the, you know, hot plate or something, the water will boil and turns to steam. So water, when you put it in your refrigerator, it turns to ice. That is solid state. And when you put water in your electric cooker, it turns to steam. So we have solid, we have solid, ice is solid. Okay, let me put it this way. We have solid, That's ice. So solid, liquid, and gas. So ice is in solid form. That means ice has the lowest entropy. Solid state has least entropy, followed by liquid, that's water. Then steam is a gas, so it has the highest entropy. So note it, understood. Now let me give you an example to show it. Let me give you an example to show it. Ammonia gas. Ammonia gas, when you react ammonia gas with hydrogen chloride gas, hydrogen chloride gas, hydrogen chloride gas. You understand? Anyhow you do it, there are many ways of doing the experiment. Anyhow you do it, there's a reaction between ammonia gas and hydrogen chloride gas, and it gives us what? It gives us dense white films. You see films of ammonium chloride, ammonium chloride, ammonium chloride. You understand what I mean now? So note it. This is chemical reaction. Ammonia gas is NH3. It's a gas plus hydrogen chloride gas, hydrogen chloride, that's HCl. So when you balance the equation, you get what? NH3. H1 comes to here, become H4. H3 plus H1 is H4. So NH4. NH4Cl. So we have NH4Cl. So this is ammonium chloride. This is ammonia gas, is a gas. This is hydrogen chloride gas. And this ammonium chloride. So it's a dense white film. So it is a solid form. It's in solid form. You understand what I mean now? So note it. Ammonia gas plus hydrogen chloride gas will give us a white films. A dense, note it, dense white film of what? Ammonium chloride. Now if the question asks you that, what is the change in entropy here? This is the chemical reaction. This is the left hand side. This is the right hand side. This is the reactant side. This is the product side. So what happens here? The reactant side are gases. It has changed to solid. So tell me, what is the entropy change? From gas to solid. That means the entropy has what? Has decreased. Don't forget that solid has the least lowest entropy, while gas has the highest entropy. So you can ask the question that when ammonia gas reacts with hydrogen chloride gas to give a dense white film of ammonium chloride gas, what is the change in entropy? The entropy has decreased. It has decreased from gaseous state to solid state. Hope you understand now. So you have to take note of any kind of question you might be given in entropy. You understand me now? Even if you are given a chemical reaction, check the state, if they are gas or solid or liquid. Then you check the change in entropy. You understand what I mean now? So that is all about entropy for now. We'll see how we love to say. So in my next class, I will discuss on enthalpy also. Then the next one is discuss on Gibbs free energy. Then we'll now look to combine the three, together. You understand? So thank you so much. Hope you enjoy the class. Once again, welcome to Mr. Palm's online class. Don't forget to like, comment, and subscribe to my channel. Thank you so much. You are blessed.